We're going to talk about solving logarithmic equations and inequalities. So section 6.9 is going to feel sort of familiar because we've solved equations throughout this chapter, and this is really just a chapter or a section that's supposed to tie everything together for you in terms of applying all the different properties and rules that we've learned to solve logarithms. So let's get started here. We want to solve this first equation. We've got log base 36 of x equals 32, or 3 over 2. There's many ways that we can go about solving this. We can use the definition of a logarithm. We can use this exponentiation idea. I'm going to show you the algebraic method because I feel like that's the method that sticks in students' heads the best. So if I have a log base 36, I can undo that logarithm by doing its inverse because I'm trying to get x by itself, right? So I can take and do what's called exponentiating. So I can take 36 raised to the left, 36 raised to the right. And what I end up with is, these are inverses of each other. I get x equals 36 to the 3 over 2. All right, and that turns out that's the square root of 36 cubed. But in Desmos or in your graphing calculator, you can just type in 32 raised to the 3 over 2. Yeah. And you get 181.0, I guess we'll go 2 decimal places, 181.02. Okay, so that's it on that one. Let's go to the next one here. Here we have log base 2 of x squared minus 4 equals log base 2 of 3x. They're already one logarithm on each side with the same base. So what we can do is we can go from where we're at here to just straight to x squared minus 4 equals 3x. And now I have a quadratic equation. I have to solve this using the methods that I've used to solve quadratic equations all year. It's going to be x squared minus 3x minus 4 equals 0. And then I can either factor this using guess and check or the magic x method. It's up to you. This one isn't too bad, I don't think. I've got x and x here. It's got to be numbers that multiply to give me negative 4 and combine to give me negative 3. That's going to be minus 4 and plus 1. So that means my solutions are x equals 4 and x equals negative 1. And then from there, we're going to check, are either one of these extraneous solutions? The answer is yes. If you put in negative 1 here, you'll have the log of a negative, which is impossible. All right, so that one is out, and we're left with x equals 4 as our only solution. Let's let the fun continue here. So log base 9 of x squared minus 4x, log base 9 of 3x minus 10, same kind of thing going on here. I already have the logarithms on each side. I already have one logarithm on each side. So I can go straight to this, x squared minus 4x equals 3x minus 10. Now, this might not always be the case where you have a one logarithm on each side, so you can jump right to here. You might have to use the properties of logarithms to condense one side and then go from there. Or you might have to change, you might have something like this where there's a log on one side and you've got to turn it into an exponential to solve. It's just going to be different ways, different rules that you're going to have to apply in different situations. This turns out to be just a quadratic equation. And so we've got x squared, and then I'm going to subtract 3x from both sides. And I'm going to add 10 to both sides. So I end up with this. Negative 4 minus 3 is minus 7x plus 10 is equal to 0. Factor that, if possible. So let's check. We've got x and x. We got numbers that multiply to give me 10, combine to give me negative 7. That's going to be 5 and 2. That's going to be minus minus. That gives me a positive 10 when I multiply and a negative 7 in the middle. And then I get x equals 5, x equals 2. Check, are either one of those extraneous solutions? They're not. Both of these are positive numbers and they don't result in, wait, no, I'm sorry, hold on. I spoke too soon. So when I plug in 2 here, I will get 6 minus 10, which is a negative number, so 2 is actually out. 5 is fine because it works here and it works here, but 2 is out. Sorry about that. Should have checked more carefully. All right. Last one, solving inequalities. There's really nothing new about solving inequalities. All the same properties of algebra apply in the context of logarithms. And so you can just take and notice that there's log base 4 on each side. So x plus 3 has to be greater than 2x plus 1. And then I'm going to subtract x from both sides. That's a 3, sorry. subtract x from both sides. 3 is greater than x plus 1. And then subtract 1, I get 2 is greater than x. Or x is less than 2 on a number line. It would look like this. Okay, but usually this answer is just fine. And that's really it. Like I said, 6.9 should feel fairly familiar because we've been doing solving throughout the chapter. And that wraps up section 9 and chapter 6.